All right, I'm going to start with this example number 1. And PXY is a point on the terminal arm of the angle theta that are in standard positions. So we're going to determine the sine, cosine, and tangent of the following points and draw a sketch. So I'm going to make this first Cartesian plane here. This is going to be A. This is going to be B. This is going to be C. And this is going to be D. So if I was to sketch this out, I know that point 2, 3 is on the terminal arm of an angle in standard position. Here we are. Sorry, point 3, 4, not 2, 3. Point 3, 4 is on a terminal arm in standard position. Now, there's my initial arm. There's my terminal arm. So now I have an angle here. I should call it theta. There's my theta. So I need to find out what sine theta, cosine theta, and tangent theta are. So here is my sketch. I'll make a right angle out of it. You don't need to, but I do know that r is equal to the square root of x squared plus y squared. R is going to be the square root of 3 squared. Now I'm going to take my time here and write it down. R squared is equal to 3 squared plus 4 squared. Notice how I put the coordinates, the x, y coordinates in brackets, just to avoid confusion where I'm squaring a negative. So 3 squared plus 4 squared, 3 is 9 plus, 3 squared is 9 plus 4 squared is 16, 9 plus 16 is 25. Square root of 25 is 5. So really, my radius vector r, I can put this in absolute value, is 5. So therefore, the sine of theta, and I don't know what theta is yet, but I do know that it's 4, the y coordinate, divided by my radius vector. Still going back to that definition. The cosine of theta, the x coordinate, is going to be 3 over 5. The tangent of theta is going to be the y coordinate divided by my x coordinate. If you notice, all of these are positive because we are in quadrant number 1. Also, if you do not, if I give this to a grade 9, and I say, well, can you calculate the sine, cosine, and tangent of this angle? Well, they don't need to know the formal definitions. You do. But they would just say, well, the sine is the opposite, which is 4, over the hypotenuse, which is 5. Cosine is 3 over 5. Tangent is 4 over 3. Anyways, I'll press pause. I want you to construct what B should look like. So this is my angle in standard position. We're measuring it from the initial arm to the terminal arm. And I have coordinates 3, 4. So very quickly, we know that sine theta is equal to my y coordinate divided by my radius vector r. The cosine of theta is going to be my x coordinate divided by my radius vector r. The tangent of theta is going to be equal to my y coordinate divided by my x coordinate. So really, tangent theta was 4 over negative 3, and I wrote it as negative 4 over 3. Note that my radius vector, be careful when you are calculating the length of your radius vector. Negative 3 squared is 9, plus 4 squared is 16. So 9 over 16, still have a radius vector of 5 here. All right, C and D. I think that we're getting a groove, so I'll let you do. There we have it. My radius vector is 5. My angle, -3, -4. Since the x and y are both negative, this is going to be in quadrant number 3. Let's proceed to finding sine, cosine, and tangent. Those are my results that I get. So what does theta look like? Theta is measured from the initial arm to the terminal arm. So that's what a quadrant 3 angle looks like. So it might be anywhere from 181 degrees to 269. Anyways, sine theta is equal to my y coordinate divided by my radius vector r, -4/5. Cosine theta is -3/5. Tangent theta is -4/3. And we have to simplify that to tan theta is equal to +4/3. Negative divided by negative is a positive. Here we are. Let's just finish this off, shall we? I'll leave this in your capable hands. So press pause. When you press unpause, magically the solution will appear. These are the results that I get. Sine theta is equal to -4/3. Cosine theta, sorry, incorrect. Sine theta is equal to -4/5. My mistake. Cosine theta is equal to +3/5. Tangent theta is -4/3. So in each one of these, notice how I've sketched them out. Now I didn't have to draw them out. I had a great definition to work with. If I drew them, this would be even more accurate. These are called trigonometric ratios, sine, cosine, and tangent. Notice that they are indeed a ratio. Later on, when you plug them into your calculator, you may get a long string of decimals. But after all, they are a ratio. That's how we should look at this theoretically. Secondly, or maybe lastly, notice how sine, cosine, and tangent follow whether they're positive or negative, really largely are determined by where x and y and the slopes are positive and negative. Anyways, let's move on to the last example. All right. So here's me thinking. I'm trying to consolidate and try to take all of this information and make it much more simpler. And I ask myself, where is sine positive? And I take a look, and all I really notice is that whether sine is positive or negative depends on only the y. Well, where is cosine positive or negative? Again, I say self. That only depends on the x. All right, last but not least, I dig deep. Where is tangent positive or negative? And self pulls through, and he says, look at the slope. Here we are. Example 2. Without the use of a calculator, oh no, what am I going to do? Determine if the values are positive, negative, or 0. 30 degrees. I'll make a quick sketch. Boom. There's 30 degrees. It terminates in quadrant number 1. So is sine of 30 degrees positive, negative, or 0? Well, sine is y. Since all the y values are positive in quadrant 1, the sine must be positive. Let's go B. How quickly can I get this done? Now, perhaps I should have explained how am I locating my angles so quickly. The top of the house here is 90 degrees. This is this is 180 degrees, right? If we go half a revolution, it's 180, and this is 270 at the bottom. Perhaps I should have said that at the beginning. And a whole revolution is 360. But I think we should likely know that from last year. If you don't, no big deal. Well, where's 200 degrees? Well, 200 degrees, I have to locate it first. There it is. It's in quadrant number 3. And then I ask myself, cosine of 200 degrees. Well, is it positive or negative? Is the x positive or negative in quadrant number 3? Well, cosine is going to be negative. Now allow me to draw a tangent. Now I'm going to draw my terminal arm for tangent. There it is. It's just a quick sketch. I get it. It's ugly. But now that's what 130 degrees looks like. Tangent is slope. Oh my God. Tangent is slope. Is that a positive or a negative slope? It's a negative slope, so tangent is going to be negative. So I'm going to switch up my picture just a little bit because I actually like a circle better. Where is sine of 250? Whoa, it's sine of 250. Well, 250 degrees is pretty close to 270, but we are in quadrant number 3. Is the y's positive or negative in quadrant 3? Negative. My last example, and I think we're done after this. Cosine of 300 degrees. There we are. There's my circle. I could also do this. I'm going to switch colors to green just to spice this up. Now, where is 300 degrees? 300 degrees is in quadrant number 4, right there. Now, cosine is x, right? Is x positive or negative in quadrant number 4? It's positive. So cosine of 300 degrees is positive. All right. I've beaten you up badly enough with this. Feel sorry. I apologize. There's a lot of content there. It's not difficult content, but weed through it. Understand it. It's so incredibly important. And most of all, if you have questions, ask.